what we have seen that suppose this is a set A and set B, and let's take suppose A, it has A and it take suppose this is our set A and this is set B and this is set C. Okay, so composition of functions we did last time, so I'll explain it more. Suppose A has an element A and its image is 1, and B has another element is B in A whose image is also suppose 1, and C image is 2, and take also D its image is, let's say, 3. So the range of A is what? 1, 2, 3. This is the range of A. But it can have more elements. The set B can have more elements. If it has more elements, then it is in 2. So suppose it has more elements like 4 and 5 also. Okay. Now B is a mapping F. This is F mapping. We used to denote F as a mapping from A to, this is F mapping. Okay. And from B to C, the mapping is noted by G. G is a mapping from B to C. So it is necessary that B must have more elements than the range of A. So that's why we are saying that range of A is a subset of domain of G. What is domain of G? Domain of G is the set B. Set B is the domain of G, but it should have more elements. Now, suppose this is the mapping from 1 to E element E, and image of 2 is F, image of 3 is G, can have the same image also, and image of 5 is H. Sorry, H. So this should be the condition. Then this is, we are going from A to C, but we are going from A to C. This mapping from A to C is called GOF, not FOG. This is denoted by G composite F. G composite F. Okay. So G composite F means F, range of F should be subset of the domain of G. So this is exist only G composite F if and only if it exists, if and only if range of range F should be the subset of, proper subset of domain of G. D for domain, domain of G. And if it is opposite, we are going from C to B and B to A, then it is called F composite G, and which is defined by, I told you that G O F of X is defined as G of Fx. G of Fx for all X belongs to A. Similarly, FOG X is defined as F of Gx. F of Gx for all X belongs to, here we are going from C to A. So C, all X belongs to C. And this is also exists only, it exists if and only if exists if and only if range of G should be a subset of domain of F. So we have to check their existence, then we can find out GOF and FOG. Without checking, do not write directly. Okay. So we are taking some examples. Example number one. Question number one. If F is a mapping, F is a mapping from R to R, and G is a mapping also from R to R. G is also from R to R, is set of real numbers to set of real numbers. G is a function from set of real numbers to set of real numbers. P is a function defined by fx is equal to x square plus 1 and gx is equal to sin x. Gx is equal to sin x. Then find both FOG and GOF. FOG and GOF, both we have to find. G composite F and F composite G. Okay. So when we are finding G composite F, first we have to check F should be, means F is a mapping from real numbers to real numbers. So you can check first this F is a mapping from this set to this set. What will be the element of these sets according to the function defined as fx is equal to x square plus 1. And this is the set of real numbers. This is also the set of real numbers. So all real numbers you have to, what you have to check with, is there any real number which you will put in instead of x will not give any value? No. Whatever number you will put here, you get the value on the right hand side. That means it has domain R. What will be its domain? R, because x square plus 1 is always positive. So we can say the domain will be real numbers R. Okay. So domain of F is a set of real numbers, because all numbers will give you, there is no number which will not give the value. Okay. Suppose there is a number here in this set which is giving infinity, that number we have to remove from this set, otherwise it will not a set. Okay. So here it is x square plus 1 is always positive. We can write by this way also, x square is always positive. So x square is always positive. You know that x square is always positive. So x square plus 1 will be equal to greater than equal to 1. We can write, so x square plus 1, that means y is always greater than 1. Y is what? Is fx. Y is what? These elements which are denoted by fx, whatever value you will put, that you will get y. That y belongs to this R codomain in CD, codomain. So here these elements are denoted by y, and elements of these are denoted by x generally. So y will be greater than equal to 1. Now try to understand whatever you are putting here, but the value of y will be greater than equal to 1, not less than equal to 1. Because if you will put, for example, if you are putting the value less than equal to 0, that is negative. So if you will put negative value f minus 1, it will give also minus 1 whole square. Because of the square, it will become plus. So this will become 1. So understood, x square is always positive. That's why x square plus 1 is always greater than 1. So this will start from 1, not less than 1. So real numbers which are not less than 1 will not mapped with any element. They are not having the pre-image inside set A, or you can say the in the inside domain. So all the elements will have the image which is greater than 1 up to infinity. Greater than 1 up to infinity. Okay. So these are the elements of the range. This will be the range. But there are other elements because this is the set of real numbers. It will have -1, -2, -3 or also there. Okay. So that means it is showing that now we will see the next part. Then we can say that now next part is it is a mapping from again real numbers to real numbers. G is a mapping which is defined by G is equal to sign. Okay, G is equal to sign. So now we have to check that what will be the elements here for G. Sign is value of sign. What is the value of sign? Sin x is always having the values between -1 to 1. -1 to 1. So -1 to 1. -1 to 1 is greater than -1 and less than equal to 1. Real numbers means it will also have 1.1, 1 point thing, all numbers will come. So that means, but x, if you will put any value of x, here you will get the value. But whenever you are putting any value of x, but sin x will give you, here you will get only -1 and between -1 to 1 value. Are you understanding? When whatever you are putting the value of x, but sin will give you only the values which are lying between -1 and 1 for all x belongs to R. You know that because you have seen the sin 0 degree is equal to 0. Here you are getting 1, and here -1 sin 0 degree 0 sin 90, sin 0 degree 0 sin 91. Then like this, the graph will touch to the -1 to +1. The maximum value -1 +1. So this is the graph of sin x. So sin always lies between -1 and +1. Whatever value, but sin will give you can put any value in sin, -1, -2, -3. We know only that standard value 0, 30, but it is also there. If you will put in the scientific calculator 0.34 sin 0.34, you will get some value, but the value will come between -1 to 1. So that means every element of this -1 will also give some value here, but this will be between any value between -1 and 1. This will also give, all will give. So this will be also mapped this one. So this proves that the range of f is a subset of codomain of G. Okay. So from this we, we can explain this like this, and then we can write, since range of f is a subset of subset of domain of G. Therefore, G composite f G composite f exists. Now we can find out. Okay, this I have done for G. So now write G of x will be equal to G of fx, and now put fx. What is fx? Fx is equal to x square plus 1. So G into x square plus 1. And gx is equal to sine x. Therefore, g x square plus 1 will be equal to sine x square plus 1. This is the value of G composite f. Similarly, we have to show for FOG range of G. Now for FOG, from this only we can say that range of G. What is the range of G? Range of G is -1 to -1. This is the now okay. This is the range. So domain of f is R and range of f is equal to minus 1 to infinity. Range of f is 1 to infinity. Range of f is 1 to infinity. But when you are going in the reverse order, so -1 plus 1, -1 to +1, this will become the range of G. Okay. So range of G will be equal to -1. We are going to this side. Now when we are finding G of f, so we did this. Now we are going in the reverse order, this order. We are going back from this order. So when you go this order, this will become the domain, correct? This will become the domain, and this will here it will become the range. Okay. So range of G will be equal to, now you can see this in this one -1 to 1. So here you have range of G is equal to -1 to 1, and domain of f means real number, because this we are going in the reverse order. So every number will give the value here. The domain of f is a real number. So here it is proved that range of G is a subset of range of G is a subset of domain of f. So hence f composite G also exists. When it is exists, we can find out the value f of f composite Gx will be equal to f of Gx, and Gx is what? Sin x. Gx is sin x. So f of sin x, and fx is equal to x square plus 1. So that means it will become sin square x plus 1. So actually we should check also whether it exists or not, then we can find out. So directly also we can say, on analyzing directly we can say that yes, domain of this, like example number 2, we are taking next question. If f is a mapping, f is a function or mapping, same thing, 0 to infinity, from the set 0 to infinity to all real numbers, and G is a mapping from domain real number, and which codomain is also real number, be defined as be defined as fx is equal to under root x, and gx is equal to minus x square. Square is not in this minus, only on x. X is minus x square minus 1. Then find both. Then find the composite f and f composite g. Okay. So first, so f is a mapping from 0 to infinity to the set of real numbers, correct? And defined by fx is equal to under root x. So only you cannot put here negative number. That's why 0 to infinity all positive numbers. So we have taken all positive numbers. So domain of obviously this set A is the domain. Only range we have to take. So domain f is equal to 0 to infinity, interval from 0 to infinity, both included, and infinity do not include infinity. Always infinity cannot be included in the interval. And for x, that means x is always greater than 0 for all x belongs to R. Then only root exists. That's why. So range, what will be the range now? Domain is this one. Okay. So whenever you are putting 0 to positive numbers, right hand side also you will get 0 to positive numbers. So range will be same. That means the range of f will also be the same number. So we missed one thing here. Range, it can be equal to all. Same, it can be same or less than. So here we are getting range of domain and range. So range of f we got. Now we will check for another second function. G is a function from R to R and defined by gx is equal to minus x square minus 1. Minus x square minus 1. Now from this you can see that domain, obviously all real numbers we can put domain of G will be the set of real numbers. But for finding the range of G, x square is always positive. From right hand side you can check what will be the values when we are putting here value of x. Okay, so x square is always positive. And in inequality, if you are multiplying by minus both sides, the inequality will change. Why? Because if 6 is greater than 3, 6 is greater than 5, if 6 is greater than 5, if you multiply, then minus 6 will become less than minus 5. So whenever you are multiplying both sides in inequality, this inequality will be reverted. So here we are just changing its inequality. Greater than will become less than. If it is less than, it will become greater than. Now we can add both sides, minus 1 here also, here also. So that means fx should be less than equal to minus 1. Minus 1 to any number less than minus 1 up to infinity. So whatever value you will put here, you will get always less than minus 1. So gx will be always less than minus 1. That means the range will be from range of g will be equal to minus infinity to minus 1. Okay, now you can check. You can check the for GOF. Okay, first we will check for GOF. So range of f is, we have to check range of f is a subset of domain of E or not. So what is the range of f? Range of f is 0 to infinity. And domain of G, what is the domain of G? Is a scale number. Yes, it is a subset. Therefore, G O F exists. When it exists, we can find out. To find G O F is equal to G of f of x is equal to G of fx, and G of fx. What is f? Fx is under root x, and G x fx is under root x. Gx is minus x square. So this will be minus under root x square minus 1. Root x square is x, so minus x minus 1. Okay, then you have to check second thing. Now you can check range of G. Range of G is a subset of domain of F. What is the range of G? Range of G is minus infinity to minus 1. And domain of F, what is the domain of F? Domain of F is 0 to infinity. The domain of F is bigger from 0 to infinity. Zero to infinity, all positive. Range of COF. So we have seen the range of F. So range of G is a domain of F. Yes. So range of G is a domain, is not, it is not a subset. Okay. So minus infinity minus 1 is negative. Here it is positive. So this number will not come here. It is not a subset of this. Okay. So we can say that minus, I have written in mathematically, it is not a subset of this. Therefore, F composite G does not exist. We will not find out. Does not exist. If you will not check it, then you can find out. You can do it like this: f of g, f of dx, and you can put the value. You will get the answer. You will get the answer, but it is not existing, so we cannot do it. So that's why we have to check also. So here you are not getting the subset. That's why it is not existing. So we cannot find out its value. Okay. We have seen the following definitions. Some definitions we have seen that identity, you have to remember these things. What is identity function? It is denoted by I actually. So identity function is actually fx is equal to x. You define it, it will be fx is equal to x for all x belongs to R. Okay. So instead of that means you know that identity function will have 1, 1, 2, 2, 3, 3, 4, 4, but it is denoted by I. So Ix is equal to x. Second thing that you have to remember, if a function, if f is a function from A to B is 1, 1 and on to 1, 1 and on to means bijective. 1, 1 on to means what? Bijective. It is a bijective function. Then f is invertible. Then we can write its inverse. Then f is inverse. Like we have seen the condition, if range of f is a subset of domain of G, then only we can write GOF. Similarly, if F is 1, 1 and on 2, if you will prove then F is invertible. Invertible means we can write its inverse. How to write its inverse? That I will tell you. So it is invertible. Just you remember that. So we have to prove one thing, invertible. So what is the inverse of this one? F, if F is a mapping, here we are considering F is a mapping from A to B. A to B, na? This is A to B. So F inverse will be the mapping from B to A. That is called the inverse of F. Third point, if this is important point. So to prove that F is invertible, we can prove 1, 1 and on 2. And by using the composite functions also we can prove that F is invertible. Suppose F is a mapping from A to B. Here if you have given only one function, you can prove 1, 1 on 2 and you can find it inverse. And if you have given F is a function from A to B in the composite form, is G is a function from B to A. B to A. Opposite. B2 functions. B2 functions such that G composite F is identity in A. What is the identity in A? Or you can better understand if you will find G composite F of X. You are finding G composite F of X is equal to X. Then and also opposite of this, G F composite G, F composite G will be identity in B. That is, if you are getting F composite G of Y, you will take Y is equal to Y. Okay. Then we can say F and G are inverse of each other. So these are the two things to prove the inverse. So next time we will discuss. Therefore, we can say G is the inverse of F. Okay. So next time we will discuss the algorithm and we will do the questions on inverse also.